review, I guess. Um, Nothing here is new, but reviewing what you learned previous years before we get to Unit 3. So let me show you what a proportional table looks like. Here's a table of values, and we're talking about this is my x, this is my y. So let me start filling in some of the things. So it's my x-axis, which is going to represent the number of tickets sold. So all these numbers are going to be talking about the tickets. And my y-axis is going to be the total that you spend at movies, wherever you buy tickets. All right, so don't believe me when I say it's a proportional table. We have to prove it, right? So it's proportional. Well, in order to be proportional, there's something called constant proportionality, meaning think about there's a number here that I multiplied the x values to get the y values. 1 times something is 4, 2 times something is 8, 3 times something is 12, 4 times something is 16. And obviously we know that number is 4, so I can write a 4. 1 times 4 is 4, 2 times 4 is 8, 3 times 12 is 3 times 4 is 12, and 4 times 4 is 16. So this is called your constant of proportionality. All right, and it's a number that you multiply x to get y. It's a number you multiply in this column by to get the y. So even here, we can go ahead down here. Excuse me, down here, and answer the question: what's the constant proportionality? Constant proportionality equals to 4. And by the way, k represents constant proportionality. So the letter k stands for constant proportionality. Now, that's also known as your unit rate. So going back to, I don't know, 5th grade or 6th grade, I'm going to circle the unit rate here. The unit rate is when we're comparing two quantities where one of the quantities is 1. Right, so let me write the unit rate here in words. What is the unit rate for this scenario? For every one ticket, right, I pay $4. That's your unit rate. So $4 per ticket. That's our unit rate. I don't know it's proportional. It's proportional if you take any of these order pairs 0, 0, 1, 4, 2, 8, 3, 12, 4, 16, and they'll all be multiplied by the same constant proportionality, which, as you can tell, it is the case. All right, so that answers our first question. This table is proportional because for every ordered pair, meaning the 1, 4, 2, 8, 3, 12, constant proportionality is 4. Right? So if I bought 5 tickets, it'd be times 4. If I bought 20 tickets, it'd be times 4. So everything is times 4, times 4, times 4. Same constant proportionality, the same unit rate, same cost. Right? Every ticket is $4. Okay. So let me put that in a graph. Now this is a proportional relationship which we just established. How does this look in the world of graphs? Well, first let's call this, I don't know, let's give it a title, ticket prices or ticket costs. Right, that's the title of our graph. Let's label our graph. Let's label our x-axis. We don't need too many numbers, so I'm going to skip by 2. So every 2 square, 2 boxes is 1 unit. So 2, skip 2 is 3, skip 2 is 4, skip 2 is 5, skip 2 is 6. I could have done, that's a 1, that's a 2, and put it, but since I don't need too many numbers on the x axis, I can spread them out. Going up and down, I'm not going to go by ones because I don't think it'll fit. I could, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, let's go by 2s. Make that a 2, 4, 6, 8, 10, 12, 14, 16, 18, and we'll go one more. All right, so as long as the intervals between your x values are the same, and they don't have to necessarily be the same interval as the y, But as long as between the numbers in the x-axis is the same, the intervals, and the intervals between the y values are the same, we're good. Let's start plotting this. 0 tickets, that makes sense. I pay $0. So there's my first point. $1, I pay 4 tickets. I pay $4. Sorry. $2, I pay 8. $3, I pay 12. $4 be 16. So remember what you've done previously. A proportional graph, right? A proportional graph. It's going to look like this. It's going to be if I connect the dots, and I'll explain to you if I want to connect the dots or not in a second. But if I were to connect those dots, right, these dots would form a straight line, and it would go through the origin. It goes to 0, 0. So that's what a proportional graph looks like. Now, if that started over here, for example, right, and I had that line, for example, this line would not represent a proportional relationship. What's the reason? It doesn't start. It's a straight line, but it does not go through 0, 0. So you have to make that clear. So one last thing, we have to represent this as an equation. Every relationship that's proportional comes in this format. Y equals k times x. So let me read this. To find y, so if I wanted to find numbers in this column, the total cost. If I want to find the total cost, so y represents the total cost. If I want to find out the total cost that I'm going to spend this evening, what do I have to do? Well, you're going to say, that's easy. You're going to multiply 4 by t, and t representing the number of tickets. So my equation can be in two forms. One, it can be using the letters in the context of this story. So t for total, $4 times the number of, actually, instead of t, I'm going to write my cost. Cost for the evening is going to be 4 times the number of tickets. If you used y and x, instead of c, you would use y. 4 is the same, and the x. So what does the c represent? The cost that you're spending for the evening. T, number of tickets. And what does the 4 represent? 4 represents the cost per ticket, right? That's what 4 is. Every ticket is $4. So this is sort of the summary of what you need to know before we start the unit. Okay, so you need to know what the unit rate is. Here's my unit rate. For every one ticket, I paid $4. Where's the unit rate on the graph? Well, on the graph, it's right here. It's always going to be here, 1 and something. In this case, let me circle that. The order pair 1, 4 represents the unit rate, where 1 is the one ticket, and 4 represents the price per one ticket. And notice that this 4 and these 4 are all the same, so this 4 is also known as your constant proportionality. Okay, so sort of gives you a little refresher course. So we're going to repeat this a few times. Okay. The second question. Let's see if this works. Lower. So now let's. What does the order pair 0, 0 represent in the context of this represent in the context of this situation? It means that if I buy 0 tickets, I pay $0. That's what it represents. Let's look at a non-proportional table and look at how slightly different it could be. So again, I'm going to use the same scenario. I'm going to write cost here for the evening. Cost of you going out. Cost of Friday night, right, with your family going to the movies. So let's label this as my y-axis. It's the total cost that you're going to spend. This is my x-axis, which is the number of tickets that you're going to buy. But notice there's a slight change here. It says $0. So let me actually label some numbers. 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets. Cost is a little bit different, notice. So I'm going to go, let's go by 2s. 2, 4. So let's go by 2. This is 2, this is 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so now here's the one difference you can see right off the bat. 0 tickets, you're paying $3. So your starting point is not the origin, but right here. How can we explain this guy here? How come is it that I haven't paid any tickets to go to the movies with my family, but yet I'm already down $3? Well, you can say you bought a bag of popcorn. Or actually, that doesn't make sense because you got to get in to buy a bag of popcorn. Maybe, well, actually, you went to the deli and you bought a bunch of candy, right? Because you don't want to spend the overpriced prices at the movie theater. So you went to the deli, spent $3 on candy. Or how about this? You went to the movie theater, but this movie theater charges for parking. So even though you didn't buy any tickets yet, guess what? You already paid $3 because you had some extra expenses. So it doesn't start at 0, 0. $1 would be, well, 1 ticket. So 1 times 4 is 4. Then you have to add the 3, which is 7. So $1, you're already at $7. 1 ticket, you're already at $7 in expenses. 2, well, it's 2 times 4, right? Because every ticket is 4, and then plus 3. That gives you 11. So 11 would be right here. 3 tickets, well, 3 times 4 is 12, plus 3 is 15. That's how you get 15. So 3 is 15. 4. 4 times 4, and then I'm going to add 3, and that's going to give me 19. So notice that, and I forgot to mention something. I'm connecting the dots to show you what kind of line it forms. It shows that this is a straight line, right? But does it go through 0, 0? This table is not proportional because it does not go through the origin. Doesn't go through 0, 0. Doesn't mean it doesn't start 0, 0. Doesn't go through the origin. Is there a unit rate? So basically, if you think about it, am I multiplying all these numbers by the same constant proportionality? It's the same number over and over and over. Well, how does 1 become 7? Well, 1 times 7 is 7. So if that's true, if this table was proportional, everything should have been 7 times 7 times 7. But you notice that 1 times 7 is 7. It works here. But 2 times 7 is not 11. So it fails. 3 times 7 is not 15. 4 times 7 is 19. Not 19. So are we using the same constant of proportionality here or not? So there is no unit rate. There is no unit rate. Is there a constant proportionality for whatever pair I want to use? So think about it. There's 5 pairs here, 4, 19, 3, 15, 2, 11. Is the same constant proportionality being used? No. So again, there is no constant proportionality. Now notice that the ticket prices were the same. It's $5. So when I asked you for the equation, it's asking you how can we get this total cost? How can I find the total cost? So what were we doing over and over when I write times 4 plus 3 times 4 plus 3 times 4 plus 3 times 4 plus 3? So the equation is going to look a little bit different. It's not going to be just y equals 4 times the number of tickets, right? So besides multiplying the number of tickets times 4, what else did we do? We did a plus 3. So notice that this was different. The previous equation from the previous problem, when the relationship was proportional, it was just y equals 4x. There was no plus anything. You're not paying for parking or extra food or anything. You were just paying for the tickets. When it's non-proportional, it's going to have something different. It's not going to be in the format of just y equals the constant proportionality times x. Okay, so here's the equation that represents this relationship. So proportional? No. Is there a unit rate? No. Can I say that, hey, here's my unit rate, right, where it says 1 ticket is $7? Is that true? No, it's not true. Because if that was true, then 2 tickets should have been 14. And we know already that's not true. Look, it's actually 11. Okay, so difference between proportional table, proportional graph, and a non-proportional table, non-proportional graph. Well, as far as the graphs goes, that's much easier. It doesn't go through 0, 0. So non-proportional doesn't go through 0, 0. Look, it starts here. The y-intercept is something else. Okay. If you look at the table, if this was proportional, every time you see a 0 for 0, the cost should have been 0. That's proportional. So, but when it's not proportional, because it doesn't go through the origin, right? This is the y-intercept is going to be somewhere else. It's going to be 0 and 8 and 0 and 20. I don't know how much you pay for parking, right? Is there a unit rate? Is it the same price, right? Are we multiplying this by the same cost proportionality by the same unit rate or not? Okay, so that's what you have to get out of this particular example. So let's do a few more. 3. All right, same thing, just reinforcing what we just talked about. Sam goes to the bank, opens an account, and his intention is to deposit $45 out of his paycheck every week. So let's fill in some values here. 0 weeks, I'm just making this 1 week, 2 weeks, and I selected these because they're easy. So he opens a bank account, hasn't worked yet, so he has $0. Hopefully that makes sense. After 1 week, finish the week's working, gets his paycheck, takes $45, goes to the bank, and puts it in there. So after 1 week, he has $45. After 2 weeks, well, he's going to repeat the process. Times 45, it's going to give him 90. 3 weeks will be 135. 4 weeks will be 180. Hopefully that makes sense. So now if I were to ask you for, hey, what's that constant proportionality here, right? How's the 1 times what's 45, 2 times what's 90? Well, it's already given to us right here. This line here, when we're comparing it to 1, it's actually the unit rate line. We know how much he's depositing per week. And that would be 45. So it's times 45, times 45, times 45, times 45. So that's known as our K, our constant proportionality. Our unit rate, right? The same number shows up in our unit rate. What is the unit rate? It is the amount saved per week. So for every 1 week, he saves or she saves $45. That's our unit rate, right? The price per week, the amount of money he saves for 1 week. What's the equation? Well, ask yourself. So this is my X column, this is my Y. How do you find Y? What do you have to do to find this column right here? The amount he saves. Well, to find the amount he saves, which is represented by Y, what are we doing over and over again? We're going to take 45 and multiply by the number of weeks. You want to know how much money he has after 10 weeks? 45 times 10. You want to know how much money he has after 32 weeks? Multiply by 45. So it's 45 times whatever number of weeks, which we call X. So there is your equation. Notice there's no plus something or minus something, right? It's just Y equals 45X. So this is the equation of a proportional relationship. This is a table, right? 0 comes with 0. Same constant proportionality. Notice that for every week, I always multiply by 45. Explain what each part of the equation represents. Well, Y, this guy represents the amount saved. All right, so we could have used the letter A for amount saved. X represents the number of weeks. What does 45 represent? So $45 represents the amount saved per week, right? It's $45 per week. That's what 45 represents. Well, it's also known as the unit rate, also known as the constant proportionality. Let's do a graph. So here's my X. It represents the weeks gone by. Right, Y represents the amount saved. And we're going to give it this title, Sam's Savings. That's what we're going to call this. Let's put some numbers. Here's 0, 0. We're going to go 1, 2, 3, 4, 6, right? We're going to go by 45 here. 2 boxes 45, another 2 boxes 90, 135, 180, and so on. We don't need more. So, and I keep forgetting about to discuss when to connect the dots and not connect the dots. 0 weeks, $0. 1 week, 45. 2 is 90. 3 is 135. 4 is 180, and so forth, so forth. So let me explain what I didn't explain in the previous example. 0 weeks, $0. What if we asked for, what about half a week? Does he have any money saved? Does he? Well, the answer is no, because he doesn't put any money midweek. He puts it at the end of the week. So you actually have to wait until the end of the week to put 45. So these values here, these dots here, have no meaning in the context of this problem. So after 1 week, he has 45. Let's say 2 days pass, a week and 2 days, which is about here, right? About here, a week and 2 days. Do you think that his 45 grew? No, because he hasn't gone to the bank yet. He's going to go to the bank here. At this point, at 2 weeks exactly, he's going to have 90. So these points here have no relevance, have no context in the story. So when that's true, we really don't connect the dots. Okay? So this would have been left just like this. Characteristic of a proportional graph. And the reason we connect the dots is to show you that A, is it a straight line? Yes. Does it go through the origin? Yes. So characteristic of proportional line, straight line, proportional graph, it's going to be a straight line and go through the origin, aka 0, 0. Okay. We'll do a few more problemos here. All right. Another one that's non-proportional. So let me do that. I can just reinforce the idea of that's not proportional. Same scenario. Except that in this scenario, Grandma went with Sam to the bank. And because Grandma is such a nice lady, the moment he opened the bank account, Grandma gave him 20 bucks to help him out. So we go 0, 1, 2, 3, 4, 5, and here, let's see. The moment he opened the bank account, Grandma helped him out and gave him 20. So at 0 weeks, he had $30, $20. 1 week passed. He takes $45 from his paycheck, goes to the bank and deposits. So how much money does he have? Well, he has 1 times 45 and then plus 20, which brings him to 65. 2 weeks. Well, 2 times 45 is 90 plus 20. He's going to have 110. 3 weeks. 3 times 45, which is 135. And then plus 20, it's going to be 155. 4 weeks. 4 times 45, which is 180 plus 20, he's going to have 200. So, this is what we did. So let me take advantage of this. So what's the equation? To find the amount saved. So to find y, the amount that he saved, what are we doing? What do we do over and over again? I multiplied 45 times who? Times the number of weeks, which we're going to call x. But what did we do after that? We added 20. So notice the difference between this equation and the previous one. Now, if the question, going back to the previous question here, is there a constant proportionality? Are we multiplying each order pair, each x coordinate times the same value? So if that was true, well, how does 1 become 65? 1 times 65. So this would be times 65, times 65, times 65. And you know that's not true. It's not true here, it's not true here, it's not true here, because there's no way 4 times 65 is 200. So, is there a unit rate? No, no unit rate. Is there constant proportionality? No constant proportionality. Right? Come back, erase this. Right, so is this proportional? No, it's not. What does the y represent? The amount saved. So we're still going to go through that. What does 45? 45 is the $45 per week that he saves. What's x represent? The number of weeks. What does the 20 represent? That's how much grandma gave him. Okay. Let's graph this and show you the difference. So again, here, let's go by 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180. So I'll even put 200. 1 week he has, at 0 weeks, he already starts with 20 bucks. Is it going through the origin? No. So what does that mean? Not proportional. 1 week he's going to have 65, which is about here. 2 weeks, 110. 3 weeks, 155. And again, 4 weeks is going to have 200. So again, we're not supposed to connect the dots, but I'm connecting the dots to show you that, hey, it's still a straight line if I were to connect them, But does it go through the origin? Does not go through the origin and not a straight line. Go through the origin and not a straight line. Okay. So this is not, and I'm going to write here, not proportional. Right, so there's no unit rate. You don't have to look for the 1 and its corresponding y value. That is not the unit rate, right? And that's it. Well, that's it for this problem. We have a few more. Do we? All right. So now these other examples, right? It's just going to be a little bit more practice, more repetition. So look at the first one. We have a relationship, and they give us 2 points. One is this point right here, 3 and 60, and this point here, which is 6 and 120. So if I only gave you those two, could you tell me if this relationship is proportional? What are we comparing? We're comparing gas, so let me create a table. The x value represents the gallons of gas that you have in the car, and the y represents the distance driven, distance you drive in miles. So it says here that if you have 3 gallons of gas, you can go 60 miles. If you have 6 gallons of gas, you have 120. Where is the constant proportionality? Where is the unit rate? So those are the questions that I want you to answer. And is this relationship proportional? Well, if I were to take a ruler and connect these 2 points and stretch it, oh, look at that. It goes through the origin. So according to the graph, visually looking at this, if I were to ask you, is this a proportional relationship? Yeah, it is. Let's look at the table because we have to answer a few questions. What's the constant proportionality? How am I getting from 3 to 60, 6 to 120? So to find that, you're going to always use this little formula here. You're going to divide 60 by 3 or 120 by 6. It doesn't matter. Let's do both. 60 divided by 3 is 20. 120 divided by 6 is 20. So here's my magic number here, the number that you're going to love. So it's times 20 times 20. And just because I don't have other values in this table doesn't mean I can't add them. So what if I had 1 gallon of gas? If I had 1 gallon of gas, it'd be times 20. Look at that 20 showing up again. So where's my unit rate? The unit rate, right, is two quantities compared, two quantities, but one of them, when you're comparing, is the quantity of one. So the unit rate, and I describe it with word, is that for every 1 gallon, I drive 20 miles. And there's my unit rate. On the table is there. There's my sentence. Where is that on the graph? On the graph, it's right here. And I want you to put a circle and say, hey, that's my unit rate. And 20, so remember the point is 120. What does the 20 is? The 20 is the constant of proportionality. Right there. That's my unit rate, right? The comparison of two quantities when one of them is 1, and in this case it's 1 gallon for, but I can drive for every, sorry, 1 gallon of gas, I can drive 20 miles, and that's the relationship. So look what I got. All this I got just given 2 points. Look at this one. Now, the question is basically asking, would it make sense to connect the dots? Well, let me take a look at this value right here. That would be about 0.5 gallons. Can I have 0.5 gallons in my tank? I can. Can I have, let me put a dot here. Can I have 3 point, make it a little bit to the right, 3.2 gallons? Can I have 6.5 gallons? Can I have 4.3 gallons? I can, right? It makes sense. That is possible quantity, right? I can have, so all these order pairs represent a different amount of gas that I have in the car and a different amount of distance I can drive with that particular amount. So can I do this? And you notice that there are billions and billions and billions of points in there. Instead of doing that, why don't I just get a ruler and draw a straight line? In this case, it makes sense to draw a straight line. Okay. It's not working. Every time I have to move, I have to go back here. All right. So, not a big deal. You're given 5 different cars. Car A, car B, car C, car D. And I want to know which of these lines represent a car that can drive 240 miles with 12 gallons. Well, that's not that hard, right? So let's go to 12. Here's 12. So is it car D? No, because car D with 12 gallons, I can drive that much. So that's not it. That's about 60. Car C with 12 gallons, I can drive about this much. It looks like 100, so definitely not it. Car B, 12 gallons, I can drive 240. Da-da-da, we have a win. 12 gallons, I can drive 240. And then let's do car A because we can. It was 12 gallons, and this is the point. This would be 12 gallons and about 300 miles. But the question is asking for which one can you drive 240? So car B would have been our answer. Okay, so I want you to ignore car A. I want you to ignore car A, car C, and car D, and focus. What in the world? Stop Siri. I want you to focus on car B. Focus here. So assume that you only had that point. So let me take that, create a graph table. Eventually, you're not going to need to, but just it's easier to show. So x and y. The x value is 12. The y value is 240. The x represents the gallons, right? And the y represents the miles. So this is what they gave me. So I'm going to erase this, erase everything else. So imagine that all you had was the point 12 and 240. And you're asked now, hey, your car can go, with 12 gallons, it can drive 240 miles. What about 1 gallon? Well, how would you do it? Well, you need to find the constant proportionality, this number right here. How do I find that number? 12 times something is 240. How do we find that factor there? Well, remember, to find K, our constant proportionality, our unit rate, we take the Y value, which is 240, divided by 12. And if you do that, you get 20. So I can go ahead and put a 20 over here. So now I know that no matter what, it's always going to be times 20. What if I had 4 gallons of gas? What if I had 14 gallons of gas? How far can I drive? Well, with 1 gallon of gas times 20, well, it's 20. 4 times 20 is 80. What if I had 14 gallons? I would go 280, and so forth. So look, it's 20, 20, 20, 20. Same constant proportionality. And we know this line represents a proportional relationship because of two things. It's a straight line, and guess what? With zero gallons of gas in the car, I'm going to go nowhere, 0 miles. Right, so our constant proportionality is 20, so that means that, hey, for every 1 gallon, I drive 20 miles. So, and where is that on the graph? We should be able to locate it. And again, if that's 0 and this is 2, that means this guy here is 1. Right, if that's 1, I'm looking for 1 and 20. It would be this point right here. I can go like this, and this would be 20. And that, ladies and gentlemen, I'm going to write 120. This 20 is my constant proportionality. Right, our unit rate, our price for 1 gallon. Right, ta-da! Let's do a couple more, and again, it's a repetition. A few more, 3 more, and then we're done. So let's start from scratch here. That's all they give us, one single point. And it's saying that Yasmin's truck travels 100 miles is 8 gallons of gas. That's gallons of gas. So let's assume that's always the case, and there's a proportional relationship. Right. So if I were to connect a line, start from 0, 0, the origin, through this, I could find other points. As long as your line is straight, I should say. So I'm going to create a graph. Well, because I don't have other points, right? So I'm interested in the unit rate. I know 8 gallons gets me 100 miles, but what about 1 gallon? That's the unit rate on. That's not the unit rate, right? The miles per 1 gallon. And so we're missing the unit rate. Well, X is the gallons, right? Because it tells us this is my X-axis, this is my Y. The Y-axis represents the miles. And we're given one piece of information. That's it. And I'm interested in this one. What about 1 gallon? Well, let's find the constant of proportionality, which is the number we're going to multiply 8 to get to 100. And we're going to use that same number here. And with whatever other amount of gallons that we have. So to find that number, we're going to go 100 divided by 8. And if you divide that correctly, you get 12.5. So we found our constant of proportionality. So I'm going to go back here and go times 12.5 times 12.5. So 1 gallon of gas gets me 12.5 miles. Not that great of a car. Right, so now that I know this, I can go to the graph and I can actually tell you that with 1 mile, this point right here is what I just found. So 1 gallon of gas gives me 12.5 miles. Now I know exactly what that value is, 12.5. And I needed a table, right, to find that. Not really a table, but you could have used a proportion, but I just wanted to show you what a proportional table looks like. And if I had 2 gallons of gas, how many? I'll multiply that by 12.5, I would get 25 miles. So let's see. Look at the graph. Look at 2. Ta-da! It's 25. Right? So the constant proportionality, and if you pick other points on this graph, if you look at this one, 4 comma 50 from the graph, and I add it over here, 4 gallons is 50 miles. Was it multiplied by 12 and a half? Yes, it was. So no matter what point you pick, no matter what order pair you pick, right, to get from x to y, you're going to have to multiply that by 12 and a half. What's the equation? So to find how far you can drive, take 12 and a half and multiply by the number of gallons you have in the car. The number of gallons in this case is represented by x. Is this proportional? Yes, it is. Both the table and the graph. I think you're getting the hang of it. All right, so this one. That's interesting. We have 3 cars. We already found this guy over here. We just did the truck. Yasmin obviously drives a big old beat-up truck. And the truck, we know that 1 gallon gives us 12.5 miles. That's the relationship that's given to us right here. How about vehicle A? So let me write vehicle A. Vehicle A, let me use a line. So if I were to connect I can't really see, well, on the graph, can I find vehicles A unit rate? Unit rate would be right here. So it looks in the graph that vehicle A, 1 gallon, gives me 25 miles. That's what it looks like. Let me draw another line for vehicle C. And in vehicle C, if I drew that line, it looks like 1 gallon. Let's switch. 1 gallon, it gives me, I don't know what that is. Let's move this line. Looks like 1 gallon gives me this amount, and I don't know what that amount is. I'm not going to guess. It's not a number that I can tell you exactly. But I know it's less than whatever the truck gave us, which was 12 and a half, I believe. And definitely lower than vehicle A. Vehicle A is a little better. It's not great. It's a little better. So vehicle C, I'm having problems finding the unit rate. How far I can drive in with 1 gallon of gas. So here's what I'm going to do. Let me erase everything. So you can use the graph. Right? It's not actually asking us. You know what? I'll stop. Because the question is not asking us, what's the unit rate for each car? Compare them and then tell me which one's the better car. Well, that's not what it's asking us. Just by looking at the graph, which one's the better car? Vehicle A. Because look, it's 1 gallon. It's going 25 miles. So vehicle A is the winner. Okay. Then we have vehicle C. Oh, vehicle C has a little bit different. So vehicle C is looking asking you for the constant proportionality, but notice that it says miles per gallon, aka the unit rate. Right, so the unit rate's right here. This point right here, which I can't tell what it is. This point right here, which I can't tell what it is. I know it's 1 and something. This looks like 1 and 10. The second one looks like 1 and 30. And the third one looks like 1 and 60. That one actually I know for sure. With 1 gallon of gas, I can drive 60 miles. So car C, it's 60 miles per gallon. That's the unit rate. So if I had 2 gallons times 60, if I had 3 gallons times 60, so that's repeats over and over, right? But vehicle D and E, I have no idea because I can't tell you for sure. So how do we do that? Well, vehicle D, we need to find a point that we actually know. And this one, I can actually tell you what it is. It's 180. 6 gallons gives me 180 miles. Let me create a table here. 6 gallons gives me 180 miles. So gallons, miles. How do we find a constant proportionality? Well, we're going to divide. Remember, this is x and y. Divide 180 over 6. That gives you 30. So it's times 30. So everything is going to be times 30. So what if I had 1 gallon of gas? It'd be times 30. And we just found our unit rate. So with 1 gallon for vehicle D equals 30 miles per gas. And it makes sense. Look, does that point right there looks like 1 and 30? It actually does. So this is the unit rate for that car. All right, so notice that as long as I have 1 point on the line, I can use that to find the unit rate. All right, so C we already had, which was 6, and then we've got to look for vehicle E. Well, vehicle E, let's look for a point. They give to us this point right here. 5 gallons, you can go 40 miles. Let's find the unit rate based on that. All right, so X and Y, gallons, and what is this? Miles. And it's given to us with 5 gallons, you can go 40 miles. What's the constant proportionality? Well, what if I divide 40 by 5? What do I get? I get 8. So it's times 8. Everything's going to be times 8, times 8, times 8. What if you had 1 gallon? You go 8 miles. What if you had 2 gallons? You go 16 miles. What if you had 10 gallons? You get 80 miles. So constant proportionality is 8. So the unit rate says that with 1 gallon, you go 8 miles. Okay. All right, so having the unit rate, look, if I have these 3 points right here that we see, right, the unit rate, these 3 points, so much easier to compare. I can tell you right off the bat which is the better car. So one car was 60 miles. This point is actually 1, 60. One was 130, and what was this one? 1, 8. 1 gallon, 8 miles, 1 gallon, 30 miles, 1 gallon, 60 miles. So which is the better car? Obviously, this one. Alright, so hopefully that helped you with your unit rate, proportional table, not proportional table, refresher.